Let's look at our first problem. Here we're going to add these two rational expressions. Now remember, rational expression is just a fancy word for the word fraction. Rational expression is a fancy word for fraction. So here we go. We're going to add these two fractions, 2s plus t over 2s minus t plus s minus t over 2s minus t. Now fortunately for us, in this first problem, the denominators are the same. And we know that when adding fractions, as long as the denominators are the same, all we have to do is add the numerators. So common denominator, 2s minus t, numerator, 2s plus t, plus the second numerator, s minus t. Combine like terms. Denominator remains the same, 2s minus t. We have 2s plus s, which gives me 3s. And notice we have t minus t, which gives me 0. So the final answer for adding these two together is 3s over 2s minus t. Now, again, I want to say this. That was a lot of fun because we had a common denominator to begin with. But we know that adding fractions is not that easy. Most of the times when we add our fractions, we will not have a common denominator, and the big problem is finding that kind of common denominator. Let's say we were asked to do the following. Let's say we were asked to find the least common denominator of the following fractions. 7 over 6x plus 21 and 13 over 10x plus 35. Now, in order to find the least common denominator, it's nice to have those denominators in factored form. Actually, the numerator will not play any role in this problem of finding the least common denominator, so we can basically ignore those numerators for this problem. Let's factor our denominators. 6x plus 21. Do we have a common factor? Yes, we do. 3. So we'll write 6x plus 21 as 3 times 2x plus 7. Let's also factor our 10x plus 35. 10x plus 35 equals greatest common factor between 10 and 35. How about 5? 2x plus 7. Now that we have those two denominators written in factored form, it's going to be easier for us to determine the LCD. Well, the least common denominator in this case, since they both have this 2x plus 7, that's certainly a part of the common denominator. That's what they have in common. Now the numerical portion, we have a 3 and we have a 5. So the least common denominator between 3 and 5, I know you know, is their product, 15. So that tells me then, between these two fractions, 7 over 6x plus 21 and 13 over 10x plus 35, their least common denominator would be 15 times 2x plus 7. But obviously, we won't be using the problems in this form. This is just telling us to find the least common denominator of two fractions and not doing anything with them. What we need to find these common denominators for is when we add or subtract fractions that do not have those same denominators. Let's look at a problem now. Let's try to add the following fractions. Let's add 7a over a squared plus 2ab plus b squared. Add that to our second fraction, 4 over a squared plus ab. Now, right away, I'm sure you notice we do not have a common denominator. So our first job in adding these two fractions together is going to be to find that common denominator. Well, as we saw in the previous problem where we just found a least common denominator, it's easier to begin by factoring first each denominator. So let's do that. Let's factor each one. Now what I'm going to do here, just to save some space, and hopefully it won't look too confusing, is I'm going to write the factorization of each of these denominators right under the fractions, and then we can determine the LCD. So here we go. We're going to factor this first denominator. We have a and a and plus b and plus b. Check to make sure that you're correct by foiling a square plus 2ab plus b squared. That works. Over here, we're going to factor this into a times a plus b by just taking out the greatest common factor of a amongst those two terms. Now that we have the factorization of each of these denominators, it should be easier for us to pick out that LCD. The LCD then, for these two fractions, is they have in common an a plus b. The second fraction has an additional factor of a plus b, and the second fraction has the additional factor of a. Now normally I would prefer to write the a on this side, but since there's no room, I'm going to go ahead and write it here, because again, multiplication is commutative. We can multiply in any order. But when I write it with my fraction, I'm going to go ahead and move this a out front, because that's more or less standard notation. Now that we have that LCD, we're ready to add our fractions. The first step, we need to rewrite each of these factors over, or each of these fractions over the new LCD. Here's our LCD, a times a plus b times a plus b. What we're going to do is rewrite each fraction. That's a little crooked, so I'll try that again. What we're going to do is we're going to try to rewrite each fraction over our LCD. So there we go. Remember, we found the LCD by factoring each denominator. We wrote it under each fraction. Now here's the sometimes complicated part. We're going to rewrite each fraction over this new LCD. Now how do we do that? Well, in this first fraction here, I compare my denominators. Here was this one in factored form, a plus b, a plus b. What's missing between this and our new LCD? What's missing is just this factor of a. So remember, I can multiply any fraction by a form of the number 1. So I'm going to multiply both numerator and denominator by a. Notice this makes this match up completely, and because I'm multiplying by this a, I must multiply the numerator by a as well. So that gives me 7a times a, or my new numerator is 7a squared. Let's try that with our second fraction. I know this is the confusing part. This denominator factored into this, a times a plus b. It wants to go to the new denominator, a times a plus b times a plus b. So what's missing between these two denominators? What's missing is the factor a plus b. So I'm going to add that here, but if I'm going to multiply this denominator by a plus b, I better do the same in the numerator. Why? Because a plus b over a plus b is 1, and we're simply multiplying by the number 1. Remember, we cannot multiply by anything but 1 when we do not have an equation, but as we do here, we only have an expression. Okay, now, where are we? We've got our denominator. What we need to do then is figure out what our new numerator is. We have 4 times a plus b. And I'm feeling pretty confident that you'll be able to distribute here and rewrite this new numerator as 4a plus 4b when we distribute the 4 over the binomial a plus b. Did you get that? We'll take a moment here. What did I do? I checked denominators. What was missing? One of these a plus b's. So I multiplied this denominator by a plus b. I must do the same in the numerator because I can only multiply fractions when we have expressions by a form of the number 1, which this is. I'm going to distribute this 4 now and get the product 4a plus 4b. Are you with me? It's a long process, I know. Now, we're almost there. We've got the common denominator. Now our job is just to add the numerators. Finally, something that doesn't sound too bad. So we got a little line there. We're going to write our denominator one more time. Then we need to combine those numerators. We have here 7a squared plus 4a plus 4b. Did you follow that there? We're adding these two together to get our final numerator. Our denominator was that common denominator. Now, do we have anything to factor out? Well, 7a squared, 4a, 4b, we don't have a common factor. And it doesn't look like that's going to factor because we have different terms a and b here. So this would be considered simplified form of adding these two fractions together. Now, what we're going to do then is try another problem using subtraction of fractions. This time, you'll see that it's really more or less the same procedure when we subtract fractions and add fractions. I think you know that. The only difference is instead of adding those numerators, we're going to subtract them. So let's try the following problem. We have x minus 2 over x squared minus 4, and we're going to subtract x plus 1 over 2x squared plus 4x. Again, the procedure is the same. We need to factor each denominator. We need to rewrite this as x plus 2, x minus 2, and 2x times x plus 2. Just doing the factorization there, hopefully you can follow. Now, knowing that we have that, we can definitely see that the LCD is 2x times x plus 2 times x minus 2. That is our new LCD. We're going to rewrite it, each of our fractions, over that new LCD. We're using the same procedure as we did when adding our two fractions. So here we go. I know this is a lot of writing, but it'll pay off at the end, because if we skip any steps, we're bound to make an error. So here we go. LCD is this, which we rewrote. What's missing in the first denominator, what's missing is simply the 2x. So I'm going to have a 2x here, so I'm going to multiply the numerator also by 2x. When I do, I'm going to go ahead and save myself some space and distribute to get 2x squared minus 4x. Doing the same thing with my second fraction there, I compare denominators. What's missing? Well, what's missing is a factor of x minus 2. So we're going to multiply the numerator also by x minus 2. Then we're going to do some quick foiling here to get x squared. This gives me minus 2x plus x, so that's minus x. And then we have minus 2 there. Now, finally, we've got it all together. What we're going to do is rewrite that final denominator, x minus 2, and add the numerators. Now, notice we have a minus sign, so be careful. What that does is it changes the sign of everything in the second numerator. Plus, this becomes a negative x squared, a positive x, and a positive 2. Collect like terms, 2x squared minus x squared just gives me a 1x squared or a x squared. Minus 4x plus x is a minus 3x. And finally, we have a plus 2 there at the end. And you can check to see, does this factor? Does this factor? It looks like it does because we have x squared minus 3x plus 2. So we get a bonus here. We get to do one more step. So we have 2x times x plus 2 times x minus 2 there. And we see that this numerator factors into x and x, minus 2 and minus 1. Check the factorization for yourself. Divide out common factors. We got x minus 2 with x minus 2. And what do we have left? The final answer is x minus 1 over 2x times x plus 2. There is so much involved in these types of problems. I think you need to go over it again. Just try and try your best.